Hello, welcome to this lecture on the course on modeling, analysis and estimation of three-phase unbalanced power network. In the last lecture, we have started talking about the case of the rotation matrix, which is actually used to represent the transposition of the transmission lines. So, what we have done is that we have defined a rotation matrix R phi, and these are the positions 1 2 3 2 3 1, and this matrix is 0 0 1 1 0 0 0 1 0. And then we have shown that if we do pre-multiply this rotation matrix with any vector, the effect is basically to shift the third row to the first position. Basically, I mean, this is for the vector, and also when we do pre-multiply this particular rotation matrix with an 3 cross 3 impedance matrix, the effect is also the same, that we essentially shift the third row to the first position. So, here what we say is that, this is the position 1. So, this is basically position 1. We say that I mean, these are the positions, and this is also the row, right. So, we say that, I mean, these are the positions, and basically this is also the row. So, this is the first row, this is the second row, and this is the third row, right. So, then here we can see that when we do pre-multiply this matrix R phi with a vector, what happens, that this row, that is basically the third row, comes to the first position, and then the first row comes to the second position, and of course then the second row comes to the third position. Similarly, here also, when we do pre-multiply this matrix with a 3 cross 3 impedance matrix, we find that this third row comes to the first position, this first row comes to the second position, and this second row comes to the third position, right. So, with this, now let us proceed forwards. Now, what we have is that we have that this V A B C is equal to Z A B C into I A B C. So, then therefore, what we can write is that essentially that V A, V B, V C is equal to Z A A, Z A B, Z A C, Z B A, Z B B, Z B C, and ZCA, ZCB, ZCC. Please note that this is a symmetrical matrix. So, then therefore, of course, ZAB is equal to ZBA, and of course, I mean, ZAC is equal to ZCA, and of course, ZBC is equal to ZCB. So, this is a symmetric matrix, we always know that. So, IA, IB, IC. Now, if I now pre-multiply with, let us say, R phi V A B C would be is equal to, of course, R phi Z A B C into I A B C. So, then therefore, we can say, now we have already proved that R phi into V A B C is equal to, so then therefore, I can say, so essentially from this I can say that it would be V C V A V B. So, it would be V C V A V B and we have already said that R phi into ZABC would be basically shifting the third row to the first position and the first row to the second position and the second row to the third position. So then therefore we have already said that, so then therefore it would be essentially ZCA, ZCB, ZCC, then of course ZAA, ZAB, ZAC, and then ZBA, ZBB into ZBC, and it would be of course IA, IB, IC, and of course it is same. So then therefore VC is equal to ZCA into IA plus ZCB into IB plus ZCC into IC, and then so on and so forth. So then therefore this original relations among the variables is also equally preserved. Now this we can also now this is an R phi is actually a non-singular matrix. So then therefore because it is a non-singular matrix, so then therefore its inverse exists. So then therefore its inverse is given by is actually 0 1 0 0 0 1 and 1 0 0. So it is basically, if it is basically, now R phi, let us write again R phi just to look at R phi. We will try to find out a relation. R phi is 0 0 1, and then we have 1 0 0 and 0 1 0. So 1 0 0 and then 0 1 0, that we already have, that we have already said. So then therefore I can simply say that R phi inverse is nothing but R phi transpose, right? So R phi inverse is nothing but R phi transpose. So this is an important relation. Correct. Now from this relation I can write down that R phi V A B C is equal to R phi Z A B C into I A B C. So these also I can write down that R phi into V A B C is equal to R phi into Z A B C, and then I pre-multiply, and then I R phi inverse R phi into I A B C. So this I can simply write down as that R phi into V A B C is equal to R phi into Z A B C into R phi inverse and then R phi into I A B C. Now here, now what is R phi into I A B C? R phi into I A B C would be that it would be I C I A I B, right? This I have already seen, because IABC as as IABC is equal to IA, IB and IC, right? As IABC vector is IA, IB, IC, and we know that the effect of pre-multiplication of this rotation matrix with any vector is to shift the third row to the first position, and then first row to the second position, and then the second row to the third position, and that is what it is. So, IC has gone there, and then IA has come here, and then IB has come here, and R phi into VABC is of course VC, VA, VB, and also we have already seen. So, let us just note it down. R phi into VABC is equal to VC, then VA into VB, that we already know. Now, let us evaluate what is R phi into ZABC into R phi inverse. Now, what is R phi into ZABC into Z phi, sorry, R phi. R phi inverse. So, R phi is of course 0 0 1. So, 0 0 1, and then 1 0 0, 1 0 0, and then 0 1 0, 0 1 0, and then of course we have ZAA, ZAB, ZAC, then ZBA, ZBB, ZBC, and then ZCA, ZCB, ZCC, and R phi inverse is nothing but R phi transpose. So, then therefore, it would be 0 1 0 0 0 1 and 1 0 0, right. So, it would be 0 1 0 0 0 1 and 1 0 0. Of course, we now let us do first this. Now, what would be the, we will first do this evaluation ZABC into R phi inverse. We will first do this evaluation, that ZABC into R phi inverse. So, then what would be that evaluation? 0 0 1, 1 0 0, and then 0 1 0. So, this is R phi, and then this into this. So, then first what I will get is that this, so first is ZAC, and then ZAA, and then ZAB, then what I get, ZBC, then I get ZBA, and then I get ZBB, and then ZCC, and then I get ZCA, and then I get ZCB. So, if I do the multiplication of this, so this is what we get. Now let us look at what is the effect of this. Here you see we say that this is position. So then this is basically, I can say that this is column 3, column 1, column 2, column 3, and I can also say that this is the position 1, position 2, position 3. So then I can say that here that this third column ZAC, ZBC, ZCC, it has been shifted to the first position. The first column, that is ZAA, ZBA and ZCA. So ZAA, ZBA and ZCA, this has come into the second position, and then the second original column, that is ZAB, ZBB and ZCB, that has come to the third position. So then it is as if what has happened, that basically the effect of this is, that this, I mean, third position of this will come to the. So then if I wish to basically, I mean, represent it pictorially, so then therefore what I will have, that if I have got a matrix like this, and let us say that these are my third columns. So let us say that these are my columns and these are my columns, then this is also my third column. So I can say that the effect of pre-multiplication by this is, or rather effect of post multiplication of this is, that this will be shifted here, right, and these it will be shifted here, and this it would be shifted here. I mean, that is essentially the effect. So you see that this particular column has been shifted to the first position, first column has been shifted to the second position, and the second original column to the third position. So this is basically the effect of the post multiplication by R phi inverse. Well, we can also represent the same in the case of, let us say, when we are trying to pre multiplication. So then therefore here also, suppose I do have one matrix something like this, and let us say that, let us say that let us say that these are the rows, these are the rows, and then these are the rows. So the effect of pre-multiplication by R phi is nothing but that the third row will go to the first position and the first row will go to the second position and the second row will go to the third position. So this is the effect, right. So this is pre-multiplication by R phi. So this is the effect of pre-multiplication by R phi. And this I can say that this is basically the effect of post multiplication by R phi inverse. So that is the effect of post multiplication by R phi inverse. Anyway, now here let us now complete this particular derivation. So then therefore R phi into ZABC into R phi inverse will be given by, so then therefore now R phi into ZABC into R phi inverse would be R phi is 0 0 1 1 0 0. So 0 0 1, and then 1 0 0 1 0 0, and then 0 1 0 0 1 0, and then we have just now evaluated this ZABC into R phi inverse. So ZABC into R phi inverse is that ZAC, ZBC, ZCC. So ZAC, ZBC, ZCC, that is the first column, then ZAA, ZBA, ZCA, ZAA, ZBA, ZCA, and then ZAB, ZBB, ZCB. So ZAB, ZBB, ZCB. So these we have already derived in the last. Now let us complete this. So then therefore the first would be ZCC, and then it would be ZCA, and then it would be ZCB. Of course, here also basically it will be the same thing, that this row would be shifted to the first position, and that's precisely what has happened. And then it would be ZAC, and then it would be ZAA, and then it would be ZAB, and precisely that this first row would now be shifted to the second position, and then the last one is that ZBC, then ZBA, and then ZAB. Right. So then this is the case. Now we have our original relation is that R phi into VABC is equal to R phi into ZABC into R phi inverse into R phi into IABC. And this we already seen that it would be VC, VA, VB, and this is ZCC, ZCA, ZCB, and then ZAC, ZAA, ZAB, ZBC, and this we have already seen that it would be IC, IA, IB. Right. So this is the final modified relation, and you see that these original relations hold good. For example, if we write down the original relations, we will perceive that immediately. So let us just comparison. Let us write down the equations VA, VB, VC, original. So this is the original case, original relation. This is the original relation. So this is ZAA, ZAB, ZAC, ZBA, ZBB, ZBC, So, this is the original relation, right, IA, IB, IC. So, from here, from this original relation, I can see that VA would be is equal to ZA into IA plus ZAB into IB plus ZAC into IC, and here is also the same thing. So, from here, for example, VA is equal to ZAA into IA plus ZAB into IB plus ZAC into IC, right. And from here I get that VA from the second row ZAC into IC plus ZAA into IA plus ZAB into IB. So, these two expressions of VA are identically the same, and that is what it should be, because ultimately the original relations should be maintained, and that is what precisely it is maintained. The only effect of this rotational matrices are nothing but to shift the positions of the rows and the columns. Now, let us look at that what will happen if I do pre-multiply it by R phi inverse. So, now we have again, now we have also now further we have the relation that V A B C is equal to Z A B C into I A B C. So, I can write down that what will happen to R phi inverse. Now, let us look at that what will happen. V A B C is equal to R phi inverse Z A B C to I A B C. Now, let us see what happens, that if I write that R phi inverse. So, now what is R phi inverse? So, R phi inverse is nothing but 0 1 0. So, it is, so R phi inverse now, R phi inverse V A B C is basically 0 1 0. R phi inverse is 0 1 0 0 0 1 1 0 0. So, 0 0 1 1 0 0, and it is VA, VB, VC. So, what it will look like? R phi inverse would be, so it would be VB, and then it would be VB, it would be VC, and it would be VA. Right? And then what is the effect of R phi inverse Z A B C? R phi inverse of Z A B C will be 0 1 0 0 0 1 1 0 0, then Z A A, Z A B, Z A C, then Z B A, So it would be ZBA, ZBB, then ZBC, then ZCA, then ZCB, then ZCC, and then ZAA, ZAB, then ZAC. So you see what is the effect for this pre-multiplication by R phi inverse? The effect of the pre-multiplication of R phi inverse is that we are shifting the first row to the third position, right, and the second row is going to the first position and the third row is going to the second position. So then therefore, if I look at it like this, so if I look at like this, so if this is the case, so then what happens? So then therefore, the first row comes to the second position, sorry, third position. So basically first row, see, you see first row comes to the third position, right, and then the second row comes to the first position, so it goes here, and the third row comes to the second position. So it is pre-multiplication by R phi. So this is the case, right. So then therefore, as we can see that basically the effect of the pre-multiplication by R inverse is essentially shifting the first row to the third position, and then essentially all and then of course followed by second row to the first position and the third row to the second position, right. So we will use these concepts further to see that what is the effect of this pre-multiplication as well as the post multiplication by these matrices in various combinations in the next lecture. Thank you.